Welcome. This session is to look into the input data for the Cook model. And I will emphasize that this climate or meteorological data are extremely important. If those are wrong, most things can become wrong. So we need to be careful when we define our meteorological data, and we normally need to have more than one source. If we have only one source of information, like the local meteorological data logger, then there's a big risk that we will get gaps and that we will get, some missing data. And we can accept all type of missing data in our testing of the model, but not in the drivers. The drivers should be continuous and they should be the best as possible. I will demonstrate this by looking into one new service that are on the internet. And this relatively new service called Open Meteo. It's a free weather API, and the great things with this is, first of all, that it is free of charge for limited use, and it has a lot of data from various sources. So this is a type of, I would call it, modern way to get data from many different weather services and then put them together and then make them available. Of special interest is this 80 years of historical data using an hourly resolution for any location on Earth. So this is not bad compared to what we have been used to in the former time. And how can we retrieve data then? We have to fill in something if we would like to use this interactively from the web page. So latitude, longitude, and start and end, they are the starting point. And if we should adapt now to our Norwegian sites, we have 62.9525. And we have a longitude that is 7.1722. Oh. And you remember that we were looking to a test period, and that was actually in September 23. So from the 1st of September to the last, to the 23, and then I'll fill this in, and then we should have September. That's it. Okay, then we have the time, we have the position, and then we also need to specify what are the weather variables. And you could see a long list here, and you could also see some soil data, but those soil data, they are modeled. So if we would like to compare those modeled soil temperatures, soil moisture with what we are simulating, we can do that as well. But now we should focus on the drivers. And then I select temperature, relative humidity, precipitation, and this wind speed. And in addition, we need the solar radiation variables, and they have a long list of radiation, and that's very good. now from our data logger we had the shortwave solar radiation. So that's what we could compare with, and that's the most important. But I can also say they have, for instance, the terrestrial solar radiation. That is also an input for the Cope model. And another input is the partitioning of direct and diffuse. But we take this now so it corresponds exactly to what we already have from the data logger, just to compare with the data logger. And then we go to the reload of the chart. And we see a chart showing those data for this particular month and this location. And we have a button so we can download it as a CSV file. So that's what we have done. And now everything is ready for comparing with what we have been doing when we look to it from the data logger. So I can close this, but before we jump into that, I just would like to show you one more illustration. And this is actually the layout of the experiment that I obtained from Montir. And here we could directly identify our weather station. So this is the weather station that we have been taking from the data logger. And here we have location 3, and here we have location 4. And here to the left we had this inverted peatland, and here we have a normal pipe-drained peatland. So this is for the comparison, and this is the main ditch between those two. So this gives us a little bit of closeness to what we are looking to. So thanks for showing me this picture. But now we should jump into the data. And then we had the data in our directory, and now I also should take this new CSV file that was from this downloading from OpenMeteo. So from OpenMeteo we have this in the picked up files, and we have actually I have two versions of the same here because I made the pre-exercise. But I will now copy that file to our directory, and then we can see that this file is similar to what we have been looking to before. But if I open this with, for instance, Notepad, we can see that the header is a little bit more extended. First it starts with telling about the latitude, the longitude and elevation, and also of the time zone. And then it has the variables, and the variables with certain units and certain, identification according to the OpenMeteo standard. We will now test actually a newly developed version with the Cope model that should be able to read this information as this. So we just need to open this with the Cope model. And then immediately it reads the same, and it identifies the columns. And we have to scan it to get also the dates. And I scan it, and then we see that now it has obtained 720 records that have a common step of 60 minutes starting from the 1st of September. And we could select all variables, and we could then exclude the time since it's incorporated in the PDF format. and we see now the fill out of actually the ID for the different variables according not to the standard of OpenMe2, but instead it's converted to the standard of the Cook model. And then we create this file, and we can look to this file, and we can look to one particular variable, like for instance the global radiation, and we can see that it is now in joules per square meter and day, and it corresponds nicely to these months. So this was not from the field, this was from a type of partly unknown origin, because this was delivered based on synoptic data in Norway by this OpenMe2. And we are of course interesting to compare this now with what we had from our site. So I would like to make a mixing of our newly data from the OpenMe2 with this file that we created before. So I go to this option, create new files, mixing previous files to each other, and then I click to the files that should be mixed, and then we had location-free climate with this new OpenMe2. And then we should just specify a new name for the output file, and we can call it test forcing data. That's it. And then we create this by clicking on this key. Oh. So now we have 10 variables. We have the previous 5 and we have the new 5. And if those should be compared, we can now just click on a variable from the previous data set. So I can click on this global radiation, and then I can click on the global radiation from the new. And what will we see? We see something that is maybe partly nice, but also quite strange, because they are not, perfectly matching in time. One is delayed compared to the other. And the blue one is from OpenMe2. And that was without any time zone correction, following the GMT time zone. And the red one is what I got when I used Excel to create the date string from the Norwegian data. So something is mysterious here, and we have to find out why and how we could maybe do something of this. And we can start to guess the origin. How comes that it is so wrong and so obvious? This is, as you directly may see, the summertime and the local time zone. And actually I was not very careful when I did my conversion using the Excel, because when I converted from a timestamp to a date string that was specified with the normal, the normal symbols for the date, then Excel made a type of clever conversion to the local time zone, because this was specified with a format that included the time zones. So now I would like to suggest that we should get rid of that. This is not a good thing. And of course you could say that if this is the time according to the Norway hour, and this is the GMT according to the solar hour, then I would like to prefer the solar hours of many reasons. First of all, we should avoid this jumping when we introduce the summer, and then we should have the time and the solar so they correspond to each other as much as possible. So we should look to how it comes, and then I would like to go back to this. I close those now, and then I actually go back and open this climate and location free climate only, and then we look to the data on that. This was sorry, this is now only showing the. I will read this from the beginning. Local free climate. No, it's a little bit mysterious here. Why did I get only one? Yeah, sorry for that. I was if the data are not shown up as they should, then there are some issues that is something in the memory of the program that in the previous case only showed the global radiation, but I would like to have them all. So then I returned to the browser and then I read the file from the beginning, and then I get it correctly. What I was on the way to do was to examine the data. And then if I look to the data by going to this tab Change Data, then we see that those start at 2 o'clock. And if we look to the file that I received from the very beginning, it was 00, but it was 00 as a time step that was then converted to a local time zone. So this needs to be corrected by 2 hours, and then you could do that in Excel, but I would like to demonstrate that you could also manipulate those data here in the Cook model. And to do that, so you right click on the date header, similar like we did before when we looked to the variables and we would like to convert to other units. But now I would like to move the current date backwards or forward. So I think it should be moved back. And then it should be moved back by exactly 120 minutes. That's it. And then we click on that. And then all the records here are adjusted. So now it said 00. And now we could just again save this to make sure that we have this corrected time, or corrected, it's at least the time according to the original file and not manipulated by Excel time zone. And then we can make a new mix. So we go to this create new file. Mixing, and then we had the location free climate, and we have this file called Open Meteo, and we specify a new, and I can actually use the same test forcing data to overwrite the previous file. So I do so, and then I create, and then we see that we have exactly 720 records, and then we could click to the global radiation, and now from the data logger to compare with the Open Meteo. They are not perfect. They still have a type of, shifting, and this can have various reasons. But one possible reason is that I don't know exactly now what the data in the logger represented. Many times from a data logger you have something that is the previous hour and not the actual hour. So providing we have now a shift that looks 1 hour, and that could be that now the Open Meteo or the instant value, and those are maybe representing the previous hour. So there should at least be one more possible shift in time, and I don't want to go too much into this now, because this needs to have information about the data logger and how the time step was constructed from the beginning. But we have showed that it is possible now to first of all adjust those if they are wrong, and then also to check how we can look to it. I will say that if we look to the behavior in general, in my view, it's not too bad. Of course, the sunshine is the whole region, so we should not expect too much of deviations. But if we further adjust this to be perfectly matching in time, then there should be no problem. We can look to some other variables as well. I will clear now, and then we can take to the humidity, and then we look to the humidity here. We have now a similar tendency, but not so much. But there might be some, still synchronizing the time to make sure that they are, perfectly matching. And some days they are more or less exactly, some days they deviate. This should correspond to 2 meters, and I don't know still if the local weather station are 2 meters. But it looks like the local weather station is reaching 100% more frequently than what's the case when we look to it from the Open Meteo source. But in the dry range they look similar. If we look to temperature, we also may see that the temperature drops more dramatically in the field to lower, and that is consistent with the higher also relative humidity. So I mean, for me it is obvious that it looks like the local meteorological station is of course keeping a better representation for especially a field out in the agriculture landscape, and where you have cooling in the night and you never know exactly what those synoptic stations represent. They are more the typical shortcut grassland close to some type of village where they are measuring the synoptic data. So that's obvious. Wind speed is also shifting, and now I don't know the height of the wind speed, but you know the wind speed seems to be higher, but it's a 10 meter and not a 2 meter that are the level for others. The most crucial issue for running the model is actually the precipitation. And if we look to precipitation now, we can see that it differs, but not that much, I would like to say. I think this looks promising. Many times precipitation have a high local variability, so of course it's not raining the same, but here it is raining a lot. And there are some showers that are more intensive in the local station than what they are in the open Meteo. When we look to the precipitation, it is sometimes important with the timing, but it is even more important with the magnitude. And then I normally make another representation, and to do that we should just include another window. So I include this called chart actions. And the chart action window, actually I can move this now and put it on the top here. So I can shift between this, looking to the PG variable, and then I could, no, it was young. And the chart properties. So this is the chart properties. And then what you normally can do is that you make a transformation, and instead of showing actual values, you show them all cumulated. And then we cumulated from the start to the end of this month. And then we can see again that the open Meteo has a little bit higher precipitation and we are a little bit lower. Of course there can be some failures and there can be systematic errors. The most tricky thing to measure is the precipitation, and we can say that this type of difference is, in my view, normal. And what is the true precipitation at the site? We can discuss that, and that could be, something that should be connected also when we are testing and validating the model performance. I can just show you one more thing that could be useful when you're comparing data, because now we compare the data on the cumulated way, and you see the time and you see the accumulation of two variables. Sometimes it is even more precise to not have time as independent. instead we can take another variable as the independent. So let's put openMe2 as the independent variable, and then I click on that to unclick it, and then I right click, and then I set this precipitation as the new first independent, and then we get this type of scatter plot. So now you see the accumulated ones from the openMe2 on the x-axis and the one on the other on the y-axis, and you could see that they are, you know, systematically a little bit lower. And if you would like to just see that more quantitative, we can also add a regression line, and then you see the regression, and if we click on this here, regression, then we could see that it has a slope that is not 1, but are showing a high correlation. So probably they could be used, and you could use this also regression line if you would like to substitute, for instance, missing data when you get those type of problems. Okay, but this gives us just one more way to get climate data for our simulations, and the good thing is that we can get it for any location on the Earth, and we can directly move from your local place to any other place, keeping all the rest of the parameters but only changing the climate. So I will go further in this and start to look to also how to calibrate, and what are the different tools, what are the different opportunities when you are doing a calibration. But this is so far great to see, and we look forward to come closer to the calibration procedures in the next